Hey, Algebra 2. So, turn off that sound. Today, and actually this whole week, we're going to go back and review some of the trickier ideas from the last couple weeks. I think we can all agree that this chapter was difficult. So one of the items that kids confuse consistently throughout the years, so don't feel bad if you're in this boat too. 8.5 versus 8.6, adding and subtracting fractions is similar yet horribly different to solving an equation with fractions. So what we're going to do on this worksheet is we're going to take a look at some examples. Oh good, bigger. Where we have side-by-side problems that look really, really close, except one's an expression and one's an equation. So I am going to figure out which ones we're going to do together. Aha, I figured them out. We're going to do 3 and 4 together. All right, so 1 and 2 are going to be for you to practice, but I will post a worked out answer key, so that way if you get stuck, you can try to follow my scribbly work. All right, taking a look at number 3. 3a specifically asks us to subtract those two fractions. So when I'm looking at that formula card that gives me steps, the first thing I need to do is factor any denominators. Well, there's nothing to factor. Ooh, but don't move your problem. This denominator has an x plus 4, and then this denominator has an x, and they are not the same term. They don't have any common factors. So when I go to build my common denominator, that's going to be just that. I need an x, and I need an x plus 4. So that's what's called our least common denominator. In these problems, you keep that common denominator throughout your work. So now I go back and I build up that common denominator. This first fraction has the x plus 4. He's just missing the x. So I'm going to multiply both the numerator and the denominator by an x. And then the second fraction over here, he has the x. He's missing the x plus 4. So I'm going to multiply both the numerator and the denominator by the x plus 4. So the good news is the denominator is there. You don't have to rewrite it. You already wrote it when you came up with the common denominator. The numerator, though, that's where the trouble gets thrown at you. So we have x times 5. Most humans call that a 5x. And then be careful here. You do have a negative 2 that you're trying to multiply by the x plus 4. So that means you're going to distribute the negative 2 into here. So that becomes a negative 2x. And then negative 2 times positive 4 is a negative 8. So the last step that we have to do here is just to look at that numerator and realize, oh, well, that simplifies a little bit. The 5x and the 2x is really a 3x minus 8. And then we never did anything to that common denominator. I know on the worksheets the answer keys are sometimes like foiled out. I really don't like you guys doing that, and I really would prefer you not to do that. So sorry if I've given you some misleading answer keys before. That's the answer to 3a. Now when I look over here at 3b, it's almost the same problem, except, yeah, it's really almost the same problem, but we added an equal sign, creating an equation, and it equals a 1 over x. So this is an equation where your job is to knock out the denominator. When I look at my denominators, I have an x plus 4, and then I have an x, and then I have another x. So one of the things we have to remember on equations is we have to look for what are called excluded values. Your denominators cannot come out to a 0. So if you think of like x plus 4 cannot be 0, that means x cannot be negative 4. And then this denominator, either one of these, set equal to 0, well, x can't be 0. So at the end of the problem, for solving sake, we just have to remember that if we get an answer of 0 or negative 4, we're going to have to cross it off. All right, so these questions, what you do is you put a big parenthesis set around the whole problem. And then this time, you take what's called the least common multiple, which is synonymous with the common denominator, and you multiply it out in front of this equation, so x and x plus 4 again. But the big difference here is you don't multiply to both the numerator and the denominator, it's just over 1. What allows us to do this is because it's an equation. Equations, you can do anything you want as long as you do it to every term. All right, this is the part everyone hates. I like when you guys rewrite the whole problem again. I like parentheses, you know me. But you got to space it out. So leave a little space here. Equal sign, leave a little space again. I hope I left enough space. All right, this green LCM is going to get multiplied in front of each of these. Yes, I agree. These are annoying. And those of you who were able to kind of figure out the shortcut that I alluded to on this lesson from last week, more power to you. Okay, I love that shortcut, but if you don't see that shortcut, then don't bother. All right, so each of these bubbles, we're going to see some cancellation. Ooh, that's ugly. Okay, try again, Abruzzo. All right, so we're looking for things that cancel. And the big idea is if you can't cancel the denominators, if you can't knock them out, that's bad news. That means you're screwed up. All right, so here, for instance, the x plus 4s will cancel. Over here, the x will cancel. And then over here, the x will cancel. So what we have left, we shouldn't have anything left in the denominator besides a 1, and we never write that. We have x times 5, which is a 5x. We have a subtraction sign. Now here, be careful. You have an x plus 4 times 2. So you have a 2x, a minus 2x, I should say. You know what? I'm being a little dangerous. I'm not going to distribute it yet. I'm going to say 2 times x plus 4. I'm worried about that negative sign not distributing properly for some of us. All right, then over here we have x plus 4 times 1, 1. That I am just going to write down an x plus 4. Okay, so now you have an equation. This happens to be a linear equation that we're going to solve. But first I got to clean it up a little bit. This left side's a hot mess. All right, so we got a 5x. We have a minus 2x. This will become a minus 8. Still equals x plus 4. Collect your like terms over here, right? This is a 3x. Oh, it's so tempting to skip steps on these, I know, but I think we've all seen what happens when you make a little boo-boo in the middle of the work. It's bad. All right, so I'm bringing constants to the left. Nope, variables to the left and constants to the right, which allows me to solve this linear equation. All right, here we go. You got a 2x equals 12. So x equals 6. And the only thing I got to be careful about before I like circle and say I'm done is make sure it's not one of those excluded values. 6 is not in my list of excluded values, so 6 is my answer. Now, when I look at these problems side by side, man, all that complaining I did about 8.5, 8.6 is a whole lot more work, isn't it? So keep that in mind. All right, let's take a look at number 4. 4a first. So again, comparing 4a to 4b. These are different problems, but man, they start off similar. Either way, the first step always says to look at your denominators and look for any factoring. So x squared plus 7x plus 10, that factors into x plus 5 times x plus 2. So this denominator has a new name, and it's x plus 5 times x plus 2. So now when I go and I try to figure out what my least common denominator is, well, I go through and I look at what we have. So this fraction has an x plus 2. But wait, there is a common x plus 2. So we just write it one time in our common denominator. And then I look through the denominators. We also have an x plus 5. So that is the least common denominator. There are common parts. So I think some of the trouble you are running into is some of you are coming up with what might be a common denominator, but not the least. So now we're supposed to build that up, right? This fraction over here has the x plus 2 in its denominator. He is missing the x plus 5. So we're going to multiply, technically, both the numerator and the denominator by an x plus 5. But good news, guys, this fraction is not missing anything. It has the common denominator. So our numerator, 6 times x plus 5, I would distribute that. I would get a 6x plus 30. And then this says plus 3x. And again, we want to simplify as much as we can. That's a 9x plus 30, which doesn't factor, so we be done. Like I said on the previous common denominator question, I do not want you guys, foiling out this denominator. Just leave it in factored form. Again, I apologize for any sort of answer keys that might have a different answer. All right. So comparing 4a to 4b. Well, the good news is a lot of the grunt work's already done. We already factored this on the previous question. This was x plus 5 times x plus 2. So now when I look at all my denominators, we have this extra equal sign and then another term here. That's what creates the equation and why the problem's going to come out very different. I still need to talk about excluded values. So I can't have, what, -2 and -5? And the way I'm getting that is I'm taking my factors and I'm saying they can't be 0. for my denominators. So x can't be negative 2. And then the other one would be negative 5. So at the end of this problem, I got to watch out for those excluded values. All right, my LCM. Very similar question to me asking you for a common denominator. The least common multiple of your denominators is that same x plus 5 times x plus 2. All right, so on this question, I am going to take that shortcut. The reason I'm taking the shortcut is because a whole lot of stuff is going to cancel. Like literally more stuff is going to cancel than we're going to end up keeping. So I'm going to try to save my energy, I guess. So this first fraction, when I multiply the green thing by 6 over x plus 2, the x plus 2's will cancel. So you still have the 6, and you're still going to have the x plus 5, and we're going to have to multiply those together. All right, the next fraction, oh my goodness, the x plus 5 and the x plus 2 will cancel. Y'all, you don't have anything left except for this 3x that's up top. And then this last fraction, the x plus 5 would have canceled, leaving you still with the 5, and it's still going to get multiplied by the x plus 2. So that is most definitely a time saver. If you feel comfortable taking that shortcut, go ahead. Some of you are like, yeah, no, I don't feel comfortable. That's okay. All right, let's clean this up. We got a 6x plus 30 plus 3x equals 5x plus 10. All right, we have another linear equation, so that's good news for me. I'm going to clean up this left side first. So this is a 9x plus 30. Sounds familiar, doesn't it? And then equals 5x plus 10 still. I'm going to bring all my x's to the left. And while I'm balancing, let's bring our constant to the right. Ooh, righty. Let's see what happens here. So these are gone. These are gone. Hear my neighbor's very noisy motorcycle. All right, so we have a 4x equals negative 20 way over here. And then I'm dividing both sides by 4, excuse me. And I get x equals negative 5. And I'm so happy to be done. I'm like really likely to just circle this and move on. But wait. Ah, finally it happened, guys. Negative 5. Wasn't that one of our you can't have it? It's an excluded value. So what we're going to do is we're going to actually cross this off. And we're going to say that it is excluded. I would just kind of write that down. And because the only solution we got is not going to work, that means this problem has no solution. Which actually is a solution, so don't panic. I know you're like, oh, all that work for nothing. No, the fact that you don't have a solution is your solution. All right, so your task is to finish the first couple questions on this worksheet. Like I said, I'm going to attach a PDF of me working through those questions. If you get stuck, go check it out. But please do try to practice this on your own. There's going to be a quiz at the end of the week where you got to do more of this, and we want to make sure that we have a good score. All right, good luck, everybody.